Would you do me a favor? I'd like to stop talking for a minute, and when I do, take a look at the room you're in, and above all, at the man-made objects in that room that surround you. The television set, the lights, the phone, and so on. And ask yourself what those objects do to your life just because they're there. Go ahead. Well, that is what this series is going to be all about. It's about the things that surround you in the modern world, and just because they're there, shape the way you think and behave, and why they exist in the form they do, and who or what was responsible for them existing at all. The search for those clues will take us all over the world and 12,000 years into the past, because it's in those strange places and in those long-gone centuries that the secret of the modern world lies. And you'd never believe the extraordinary things that led to us being the way we are today. Things like, for instance, why a 16th century doctor at the court of Queen Elizabeth did something that made it possible for you to watch this screen now. Or the fact that because 18th century merchants were worried about ships' bottoms, you have nylon to wear. Or why a group of French monks and their involvement with sheep rearing helped to give the modern world the computer. Or what medieval Europeans did with their fire in winter that led to motor car manufacture.
Where are we? This is Cohort, Brian. Same year, same time. But in this universe, Christianity never existed, which means the dark ages of scientific repression never occurred, and thus humanity is 1,000 years more advanced.
You've probably heard about the butterfly effect, usually explained by the idea that a butterfly flaps its wings in Brazil and causes a hurricane in Texas. Premise ridiculous. Of course they cannot do that. There are millions of butterflies. If everyone caused the beginnings of a storm, Earth would be in chaos. The thing is, that's not really what the butterfly effect is about. It's about how tiny changes in big systems can have complex results. Systems in this case could be anything from weather patterns to how big groups of asteroids move to how lots of people interact. This was originally discovered by an MIT mathematician and meteorologist, Edward Lorenz.
In 1961, Edward Lorenz was modeling the Earth's weather with a computer and found that the smallest change at the 1/1,000,000th of a decimal point could make his predictions useless. He called this result the butterfly effect.
At the time, mathematicians thought if you changed a little at the start, it would only change a little at the end. That was logical. But these systems don't behave that way, and we needed new math to understand why. In walks chaos theory.
It's the essence of chaos.
I'm still not clear on chaos.
It simply deals with predictability in complex systems. The shorthand is the butterfly effect. A butterfly can flap its wings in Peking, and in Central Park you get rain instead of sunshine.
Take nature, for example. It might seem random, but it's governed by rules, and that's why it makes shapes like this. These are called fractals, and they show us how chaos is really order. It's an infinitely complex, repeating pattern that can appear chaotic at times, but is actually order.
The story of the events and the people who, over centuries, came together to bring us in from the cold and to wrap us in a warm blanket of technology is a matter of vital importance. Since more and more of that technology infiltrates every aspect of our lives, it's become a life support system without which we can't survive. And yet, how much of it do we understand? Do I bother myself with the reality of what happens when I get into a big steel box, press a button, and rise into the sky? Of course I don't. I take going up in the world like that for granted. We all do. And as the years of the 20th century have gone by, the things we take for granted have multiplied way beyond the ability of any individual to understand in a lifetime. The things around us, the man-made inventions we provide ourselves with, are like a vast network, each part of which is interdependent with all the others. I mean, cross the road. Whether or not a car coming around the corner knocks you down may have something to do with the person you've never met fitting the brakes correctly. Change anything in that network, and the effects spread like ripples on a pond.